Okay, since it's 10 o'clock, I'm going to go ahead and get started. Anytime you have any questions, you can just unmute yourself and ask, or type over here and type over in the chat section. Okay, so we're going to do section 2.2 today, which is on functions and graphs. And the first thing we're going to talk about is how do you tell if a relationship is classified as a function or not? Okay, so a function is a relationship in which each element in the domain, which is the x values of the graph, only corresponds to one value or one element in the range, which is the y values of the graph. Okay? So the first 1, 2, 3, 4. Now remember, I'm going to be going through this handout that I put in your weekly folder. So if you printed it off ahead of time, then essentially you're seeing everything I'm going to write on the board, and then just can take the notes over in the open area. So again, a function is a relationship in which each element in the domain only goes to one element in the range. So let's look at the first few problems. Number 1 gives me a list of numbers in the domain. Which is 10, 6, and 24. And another column for the range, which gives me two numbers, which are 25 and 21. Then it has arrows going from the numbers in the domain. The arrow coming from the 10 goes straight to the 25, which means this number in the domain only went to one number in the range. Okay? What about the 6? It only goes to the 21, which means that element in the domain also only goes to one number in the range. So it's still classified as a function. The 24, where does the 24's arrow go? Just to the 25. So it is still a function, right? Because if it's not a function, for instance, the 24 would have had to have gone to the 25 and the 21. So it's only not a function if one of these numbers in the domain had two arrows coming out of it going to two separate numbers in the range. So yes, this is a function. Right, number 2. And again, remember, if I'm going too fast or whatever, you can just rewatch later and pause me. The domain numbers are -1, 4, and 8. The range number is 2. So when I'm looking at the arrows, the -1 went to the 2. -1 only went to one number though, so it's still classified as a function. The 4 only goes to 2. The 8, again, only goes to 2. So I don't ever see a number in the domain going to more than one number in the range. So yes, that is also a function, since each element in the domain only corresponds to one element in the range. All right, number 3. All right, so looking at the handout, I see that the 64 only goes to -4. 125 only goes to -5. And 8 only goes to -2. So again, once again, on this, there is not any number in the domain that goes to more than one number in the range. All right, once we see number 4, I think you'll see what it looks like when something's not a function. So the domain is going to list 2 cities, Chicago and New York. So instead of numbers, it's just cities. The range is a group of teams, Bears, Bulls, and Cubs. And then we have the Knicks, the Mets, and the Giants. So looking at my handout, I see that this element in the domain, the Chicago, goes to the Bears, the Bulls, and the Cubs. And this element in the domain goes to the Knicks, the Mets, and the Giants. So we're seeing something different here than we did on the first 3 problems. We have an element in the domain that is going to multiple elements in the range. That's what makes it classified as not a function. So that's the difference. Okay? Now, the next group of problems, it's going to give me a function, and then it's going to say, find what happens if you plug different numbers into this function. So let's look at number 4. It gives me a function, and it calls it k of, oh, what just happened? Sorry. K of x equals x plus 7. So my function is x plus 7. Then it says, let's see, what happens when you have k of 0? Which means, what happens to this x plus 7 function if you replace that x with the 0? So that's all you do, is replace this x with a 0, bring down the plus 7, do the math, and add the 0 and 7 together to get 7. There's multiple ones. You're doing the same thing over and over. It says find k of -15, k of -4, k of 15, and k of x plus 18. So once again, each time you're just going to this original function and replacing this x with whatever is in the parentheses, and then doing the math. So essentially replace the x and then add 7. So let's see, if I replace the x with -15, I have -15 plus 7. Add those together, -15 plus 7 is -8. Again, if you're not comfortable or don't like adding with positives and negatives, just punch that in that calculator. If I replace the x with -4, I'll have -4 plus 7. If I add that, -4 plus 7 just gives me 3. Replace the x with 15 now. So 15 plus 7, just add that together to get 22. So the only one that's a little bit different is this last one. So every single time, what have I done? Every single time I have taken what is inside these parentheses and replaced the x with it. So let's see, if I replace the x, this time I'm replacing it with everything that's in the parentheses. So I'm replacing it with x plus 18. Bring down the plus 7. Now, which terms can I put together there? I can't put together all of them, but I can put that 18 and the 7 together. But I still have the x. So I have x still. And then just put the 18 and the 7 together to get plus 25. Right, number 6. Same kind of problem. This time the function is h of w equals 9w plus 9. We're going to find h of 1. Then we're going to find h of -8. And then we're going to find h of 6.7. Same thing, whatever is in these parentheses, you're going to go up here and replace the w with that number. So let's see, if I replace the w first of all, I'll have 9, replace the w with a 1, bring down that plus 9. Then do the math. 9 times 1, 9. Bring over the plus 9 to get 9 plus 9, which is 18. All right, let's do it again with -8. Again, replacing the w with -8. So I'll have 9 times -8 plus 9. Nine times -8, when I multiply that together, it gives me -72. Bring down the plus 9. And then do that math. So -72 plus 9, what does that give me? -63. Again, if you don't like doing the positives and negatives, just punch that in your calculator. And the last one, plugging in 6.7. So I have 9 times 6.7 plus 9. So this right here is definitely not something that I'm going to want to do. You have a bigger chance of making a mistake doing this part of the math, 9 times 6.7, than any other part of this problem. So I would just plug that straight into your calculator, just exactly like you see it. So 9. Now, these parentheses, if you do open parentheses, close parentheses, it'll do that multiplication. So let's do open parentheses, 6.7, close. Oh, whoops. Close. And then what do I need after that? I need to do plus 9. So I do it just like that, just exactly like I have it written on the board. 9 times 6.7 plus 9, and hit enter. And it'll do the math. It'll do the math for you. So what did it give me? 69.3. in this one. The absolute value of x minus 2. So we're finding three things. We're finding f of 2, we're finding f of 4, and we're finding f of a plus 2. So let's see, the first thing we're going to do is replace this x with what's in parentheses. So what's in parentheses is the number 2. So we're going to replace that x with the number 2. So let's see, we'll have the absolute value of 2 minus 2, and then do the math. So what I need to figure out is what is the absolute value of 2? Well, the absolute value just means how many physical spaces are you away from the number 0. So how many spaces away from 0 is 2? It's 2 spaces away, right? So the absolute value of 2 is just 2. Bring down the minus 2. That's on the outside, and then subtract 2 minus 2 to get 0. Okay? That is why even if you're taking the absolute value of a negative number, like the absolute value of -7, how many physical spaces away from 0 is the number -7? That's why the absolute value, when it comes out, it's always positive. So it's always the positive of whatever is in there, right? Because you are all physically 7 spots away from 0. Okay? So that's what absolute value means. All right, let's do this one. Plugging in a 4 for the x. So I have the absolute value of 4. Bring down the minus 2. So how many spots away from 0 is 4? That's 4 spots away. So the absolute value of 4 is 4. Bring down the minus 2, and 4 minus 2 gives me 2. Now, the last one. This one's a little different. What am I replacing the x with in this part of the problem? Well, with exactly whatever is in the parentheses, which is a plus 2. So here I'll have the absolute value of a plus 2 minus 2. Now, here's the thing. I don't know what a is, right? A is an unknown variable. I don't know what it is, which means I can't just assume that it's any number I want on the number line, which means there's really nothing else I can do to simplify this problem. Since I don't know what a is, I can't bring anything out of that absolute value bar because I don't know, is a -7? Is it -4.6? Is it -3/2? I don't know. So I just leave my answer exactly like that. You can't simplify it anymore. Okay? The last problem like, oh no, we got 2 more like this. All right, so our function is x to the 3rd power. We're finding all kinds of things. We're going to find f of 0. We're going to find f of 3. We're going to find f of negative, oh, whoops, sorry, I'm going down instead of over. F of 0, then f of -1, f of 3, f of 10, f of -2, and f of -3a. Now, I'm going to show you a little trick in your calculator. Now I can go through, and this one's actually not too bad. I can go and replace the x with all those numbers and then just raise whatever that number is to the third power. Okay, but say you had a more drawn out function and you were trying to go through and replace that x in that function, and you had to square it and subtract 7 or just do a bunch of things to it. Look what you can also do. Go to your y equals and clear it out. Type in x to the third power as your y1. So remember, your x button is this button right here. So I want to type to the third power, which means if you're typing an exponent other than squared, you can use this up arrow button. So x to the third power. So now I'm going to do second table. It does all the math for me. So what you're doing is, here are the different numbers that are going into that function for the x. And then they're raising that number to the third power, and that gives you the y, which is exactly what I would be doing here, right? I would be replacing, the first thing I would do is replace that x up there with the 0. Well, look, where does it tell you? Let me go down to it. So there's where x is 0. What is the y that goes with it? It's 0, because what is 0 to the third power? It's 0. Look at your table at -1. Does it show it? Yeah. So up 1. So there's where the x is -1. What's the y that goes with it? -1. So you can use that table function to get all of these answers. What is it when x is 3? Sorry. When I replaced the x with 3, what did it give me? It gave me 27. Then you can scroll down to where x is 10. 8, 9, 10. So when x is 10, what is its y? It's 1,000. And you can scroll back up to the -2. When x is -2, what was its y? It was -8. So that's exactly what you're doing here. Here's the only one that's a little bit different since it has an A. But you can use your table to get the f of -3 part. So if I'm going to f of -3 in my table, what is the y that goes with that? -27. So there's the number part of it. Now, what about the a part of it? Well, if I'm replacing this, if I have -3a here, a to the third is just that, a to the third. So -27a to the third. All right, and the last one that is like this, where we are plugging in. Let's look at number 9. This is going to give us the Fahrenheit function. So a lot of times if somebody tells you what a certain degree is in Celsius, a lot of times that doesn't mean anything to us in America because we don't use Celsius, we use Fahrenheit. So this is the function that changes a Celsius temperature to tell us what we're used to, which is Fahrenheit. So let's see, it's saying f of c equals 9/5 c plus 32. So if somebody comes up to you and says the Celsius temperature is 25 degrees, okay? I don't even know, is that hot, cold? I don't know. So I'm going to plug it in to this formula. So essentially I'm finding f of 25. Which means I'm just going to go replace the Celsius temperature, which is the C, with what the Celsius temperature is, which is 25. So if I replace the 25, I'll have 9/5 times 25 plus 32. And since I'm not a huge fan of working with fractions, I'm just going to punch that in my calculator exactly like I see it. So I will type in 9/5. So 9 over 5. Now, if I do open parentheses, close parentheses, it's going to do the multiplication for me. So what do I need to put in the parentheses? So I have 9/5 times 25. So open 25, close, and then plus 32. Plus 32, and hit enter to see that that would be 77 degrees Fahrenheit. Okay, now 10, 11, 12, 13, and 14 are essentially doing what we've been doing, getting a function, plugging different numbers in for the x to get the y that goes with it. But then we're going to take it one step further, and we're going to use those points that we come up with to show what that graph looks like. Okay, now I'm not going to freehand all these graphs because we don't have enough time to do all that. I want to just come up with the tables, and then I'll share my screen and I'll go into the My Math Lab and remind you and just kind of do some more graphing on My Math Lab. All right, number 10. The function is f of x equals negative 2x plus 2. And then it gives me a table to complete. It has an x column, and it gives me different numbers for x, which are negative 2, 0, and 2 on this particular problem. And then it gives me a column, and it calls this column f of x, which brings up another important point, and the important point is that f of x and y mean exactly the same thing. Your y's are a direct result of whatever you plug in for x, which means they are a function of whatever your x value is, okay? So let's see, my first function is negative 2x plus 2. It wants me to plug in negative 2, 0, and 2. Now I could go do all that and write it all out over there and take up half this board doing all that math. Or I could go to my y equals and use my table function. What is my function? It's going to be negative 2x. So negative 2x plus 2. All right, now when you're doing your homework, got to go ahead and graph that to look and see what you're about to graph, because remember, when you're graphing in My Math Lab, before you start plotting points, you've got to let Math Lab know what kind of shape you're about to draw. So I know it's going to be a line. Now, remember how to get to the table. Hit second table. So there's everything you need to do to plug in to finish up that chart. I need to know what is my y, or my function of x, when x, the first one is negative 2. So there's where x is negative 2. What's the y that goes with it? 6, right? And then just go on down that chart. What is it when the x is 0? 2. What is the y when the x is 2? Well, when the x is 2, the y is negative 2. So what you're going to do, and we'll do a couple of these in Math Lab in a second, is complete this chart. Then once you complete that chart, it's going to ask you to graph it. Okay? So since we're not freehanding anything, I'm not going to freehand all these. We'll just graph them in Math Lab in a minute. Number 11. The function is f of x equals 3 minus the absolute value of x. And then my chart numbers, it gives me again my x and y, or my x and f of x. And the numbers it wants to use are -2, -1, 0, 1, and 2. So do y'all remember what shape this is going to make? Since it's an absolute value graph, it's going to make that V shape, right? So that's what we would have to go over and tell Math Lab is that we're about to draw a V. But even if you don't remember, I type this in to my y equals. So I need y equals cleared out, 3 minus. Now, remember where the absolute value is. So if I go to the math button and then go over 1 to number, the absolute value is the first thing listed under there. So hit your enter button, and there comes your absolute value bars. So what are you going to put inside those absolute value bars? That x, right? Because that's what the function is. 3 minus the absolute value of x. So again, even if you didn't know that that was going to make the V shape, just go ahead and graph it. Now, I'm going to go to my second table again, because I need to fill out that chart. The first thing I need to know is what is the y when my x is -2. So there's my -2. The y that goes with it is 1. And then just go down that chart essentially. So let's see, I'll need 1. When x is -1, my y is 2. When x is 0, my y is 3. When x is 1, my y is 2. And when x is 2, my y is 1. So remember, the V graphs and the U graphs, at some point, if it's this or this, it's because your y's start mirroring each other, right? They're the exact mirror of each other. And that is because at some point in the graph, your y's are going to match. That's what makes it be a V or U. Okay? So again, this is one of the ones that I am going to work in Math Lab when we get through these. All right, let's look at number 12. All right, I'm not going to work every single one of these. I'll do this number 12, and then I'll do number 14, and then we'll go on to the end of these so we can get into Math Lab. All right, so this is definitely one. I don't want to do all that handwork, right? If I was doing all the handwork, I would have to take each one of these 5 numbers, go up here to the function. Everywhere I saw an X, I'd have to put in the number that I'm choosing to plug in. So I'd have to plug in -1 and do -1 squared, -2. Plug in -1 again, -2. And you'd have to do that over and over for each one. So let's type it into our y equals x squared minus 2x minus 2. So again, x, your squared button has its own button, squared, minus 2x minus 2. Now, this is the highest exponent is a 2, which means this is an x squared graph, which means it should be a U shape. So there's my U shape. I don't care about that just yet. I just need to fill out that chart. So again, second table. There's all the numbers that I'll need. So I'll just start with the -1. So there's where x is -1. So what do I need to put in for its y? It goes with the 1, which is what I would have gotten if I would have worked it correctly by plugging in all those numbers. So let's see, -1 gives me 1. And again, remember, this is a U shape. which means at some point during the graphing of this, the y's should start being the same to mirror each other. When x is 0, gives me -2. When x is 1, it's -3. When x is 2, it's -2. So there's where the u started happening. And when x is 3, y is 1. Okay? All right, so I'm going to skip number 13 and go to number 14. This is all the same thing. All right, x cubed plus 9 is my function f of a and f of x. And it wants me to plug in -2, -1, 0, 1, and 2. Now the main reason I wanted to just work this one again is because it has an x cubed, just to remind you how to type in those exponents. So go to y equals and clear it out. Type in x. Now remember, the x squared has its own special button. All the other exponents have to use this up arrow to get into the exponent. So x to the third. So that puts you up in the exponent. Type in your 3. Now I need to type in the rest of the function, which is plus 9. So remember, look at your cursor. I'm still up in the exponent, and I don't want to be in the exponent. I don't want the plus 9 up there. I want the plus 9 down in the same row as the x. So arrow out of that exponent to get your cursor back down into the regular spot, and then hit your plus 9. So just make sure it looks right. So it's an x cubed graph, which means it's going to be that squiggle shape. And then second table to get the numbers that you need. So there's all the numbers I need from the table. So let's see, -2 gave me 1. -1 gave me 8. 0 gave me 9. 1 gave me 10. And 2 gave me 17. So again, don't waste your time and risk making a mistake on trying to just plug all those numbers in when you can just simply use that table function. We're going to use the table function a lot this semester. Okay, now the last 15, 16, 17, and 18. So remember the first few problems where we were talking about whether or not a relationship was a function or not. And we were looking to see, did each element in the domain only go to one element in the range? We're going to do that picture-wise now, and it's actually easier. We're going to use what's called the vertical line test. Now remember, a vertical line looks like this. Right? That's a vertical line, one that goes straight up and down. If you are looking at a picture of a graph, and you can draw one of those vertical lines straight through it in any spot, and only touch the picture once, not more than once, then that graph is considered a function. So again, if a vertical line only touches the picture once, then it is a function. All right, I'm going to work the last problems all together. Here's what number 15 looks like. Number 16. Looks like that. Number 17 is this shape. Let me see if I can fit it in the screen. Yeah, I can. Number 18 looks like this. Okay, so I'm going to use the vertical line test to determine if each one of these pictures or graphs is a function or not. So let's use our vertical line. I can just use my marker essentially and make it be a vertical line. How many times does it touch that picture of that graph? It only touches it once. There is nowhere on the picture of this graph that I could touch this more than once, which means yes, this is a function. Look at the difference between this one and number 16. If I draw a vertical line right here, how many times would I touch the graph? I would touch it there and there, which means I would touch it more than once, which means yes, this is, oh, excuse me, not yes. If it touches it more than once, then no, it is not a function. What about this one? Here's my vertical line. Touched it once, touched it twice, then no, not a function. And number 18, it doesn't matter where I draw a vertical line on the picture of that up and down, I would never touch that graph more than one time. I would only touch it once, which means yes, that one is a function. Okay, so since we've gone through all that, I am going to start sharing my screen, and I'm going to go to Math Lab and do a couple of those graphs. Okay, I just don't want y'all getting stumped on certain things just because you don't know how the Math Lab works. Okay, so I'm going to act like I'm going in. Go to your portal, sign in. Over here and go to Blackboard. All right, once you're in Blackboard, you'll choose your course, College Algebra, section 23. Now remember, where you do your work is down here in My Math Lab student links. Go down to My Lab Math All Assignments. All right, and we are in 2.2, Functions and Graphs. Now, the only place I think you might get stumped is on the graphing. So let me see which one I want to do. Let's go to number 10 was a graph. So the function on this one is negative 2x plus 4. So it's similar to the one that I worked. Now remember, I'm going to go to my calculator and just type in that function, negative 2x plus 4. Negative 2x plus 4. Now, before I do anything else, I'm going to go ahead and graph that if I don't already know what shape that's going to make. So I can see it's going to make a straight line. Now, before it's going to let me graph, it's going to want me to complete that table over there. So I'm going to do second table. And then I'm going to get the numbers I need. It looks like it wants me to know when the x is negative 2, 0, and 2. So when x is negative 2, it looks like y is 8. You just come over here and put the 8. When x is 0, it looks like it goes with the y being 4. Oops. And then when x is 2, down there towards the bottom, it looks like the y is 0. Oh, whoops. Now it's going to tell you to come down here to the right bottom corner and check your answer. If you get that right, then it's going to take you to the graph. So you're going to go down here to click to enlarge. Now remember, the yellow rectangle at the top kind of gives you instructions on where you're going to go. So this says to choose a tool in the palette. So since I know it's making a line, I'll do a line. Now you can do any of the points that you just put in that table. So if I wanted to do the -2, 8, -2, and then go up 8. Now remember, since those graph bars are so small, you can look up in that top, in the right-hand side of that yellow rectangle to make sure you're at -2, 8, and it says I am, so I'll click yes. Now I'll plot another point from my table. I'll do the 0, 4, which is right there. Click it, save it, and then check it. Okay, now I am going to do the next one since it is an absolute value problem. So since it's absolute value, that's the only kind of graph that it makes you plot a very certain point instead of any point first. So let's put that one in our y equals 7 minus, remember, then I'll hit the math button, over the number to absolute value, x. So 7 minus the absolute value of x, and then graph it. So I know it's going to make that V shape. So that's what I'll tell it in a minute when I'm going to graph. So I'm going to go to my table, second table, to get my table numbers so I can finish up this chart. So let's see, -2 gave me 5. -1 gave me 6. 0 gave me 7. 1 gave me 6. And 2 gave me 5. So I'll check it, come down to the bottom right and check it. Nice work, thanks. Now I'm going to graph it. So I'm going to click to enlarge. Now, remember, it's that V shape, right? It's a V shape. Even though it's upside down, it's still a V shape. So I'm going to click the absolute value tool. Now, look at the yellow directions. Click the graph to plot the vertex. The vertex is on this graph where it comes to that point in the V. So which point is that? Okay, that's where it came to that point. So it looks like that is the 0, 7 point. So you have to plot that first. 0, 7, click OK. Now it says you can plot anything you want. So now I can just click anything out of the chart that I just made over on the right. So if I wanted to do that 1, 6 over 1, up 6, plot that point, save it, and check it. Okay, I'm going to stop sharing. After this problem, you go over number 7. It's another absolute value one. Absolutely. Yes. Number 7. Yes, so absolute value. If I went over number 7 on this, and if I did it in my calculator, now I don't want to do the next. You can skip around with this down arrow right here. If I went to number 7. So it says the absolute value of x minus 5. Okay. The first thing it wants me to do is find f of 0, which means it wants me to come over here to where my cursor is and put a 0 in place of that x. So if I put a 0 there, what would I have? I would have the absolute value of 0, which is 0, minus 5. So then you'd have 0 minus 5, which would just be -5. So it'll want you to plug in that first. Then it'll move you on to the next one. So now what am I going to put in the X spot? This 4 right here. So I'll put a 4 right where my cursor is on that X. So if I put in absolute value of 4 minus 5. So if I do the absolute value of 4 minus 5, okay, I know I'm small because I'm sharing my screen, but what is the absolute value of 4? It is simply 4, bring down the minus 5, and then do that math. 4 minus 5 to get negative 1. Oops, negative 1. Now, this is the one that was kind of had a funny one at the end, because it now wants me to replace this X right here where my cursor is with an A plus 5. Well, if I put the A plus 5 in for that X, I'll have absolute value of A plus 5. And then what's the end of it? Minus 5. Now, this is the one where, oh, I'm kind of glad you asked this question, because so I can't do anything else with that, right? Because I can't just assume what that A is. So I need to type this in as my answer. So you'll come down, see at the bottom of my screen where it has these, looks like where to type in a fraction, a mixed number. If you needed to type in an exponent, you'd hit this. I need to type in an absolute value. So see where my little pointer is down on absolute value? See how I put the absolute, that's where I want to type that in. And then inside my absolute value, I have A plus 5. Now I'm going to arrow to the right to get out of the absolute value because I don't want that last minus 5 in there. Okay? And then check. Okay? Are there any other, did that help, Lindsay?
Yeah, it's just on the problem, it's a minus 2. And so since it's an absolute value and a negative number.
Right, so that doesn't, I'm glad you're saying that because that doesn't even matter because I don't know what A is. So I can't, so if A was like 15, even though it's minus 2, so 15 minus 2 would be 13, so it's positive. So it doesn't matter if there's an unknown in there, you can't bring it out of the absolute value. You've got to leave it in there.
Okay.
Okay. All right. Any others? All right. I will save this as a YouTube video and I will put it in your week 1 folder of course content. So if you want to come back to it later, you can. And everybody have a great weekend.